All right, so here we are in our last problem of the review, problem number 8, and it's asking us to solve the problem by minimizing z, which is equal to 2x plus y, subject to the constraints. And we could do this by graphing, theoretically, because it is just two dimensions, it's x and y, so we could theoretically find our x and y intercepts and graph everything, find our shaded region, test our corner points. But the real focus of this class was getting you ready for simplex and dual. So let's go ahead and use one of those methods. Now, this is a good fit for dual because it is minimize and everything is greater than or equal to. But for me, I would rather practice the general simplex method because that has more steps. It's a little harder, and it's the bigger focus of this class. The dual method is just a few little steps and then it's a standard simplex problem. So usually students struggle with the general simplex, so I'm going to do the problem that way. All right, so let's take this through. General simplex, or simplex in general, can only do maximization. This is a minimization. So general simplex says first thing we need to do is convert this to a max problem, and we do that by reflecting. So multiplying through by a -1. So we're going to have negative z is equal to negative 2x minus y. And then usually in the problems we had in the homework, we had C's and P's. So you can leave it as a negative Z if you really want. But since I don't know, I don't like having a negative there. I'm going to recall that since the max, I'm going to change it back to a P. That's what I think most students usually do for this. Okay, so there we go. Now, to be able to put this in a matrix, we need to rearrange this so the p has a positive leading coefficient. So I'm going to add my variables over to the other side, which will give me 2x plus y plus p equals 0. So there we go. There is my objective equation. Now what I need to do is build all of my constraints. So these are all greater than or equal to's. So for my slack variables, because it's greater, I need to bring it down. I need to subtract. So I'm going to subtract a q. So minus q equals 84. My next one would be 3x plus 2y minus r, which is equal to 60. And then my final here would be 3x plus 6y minus t is equal to 72. And we can do our check if we want to make sure we can actually use this method. Standard simplex only has one requirement, or sorry, general simplex only has one requirement. The variables have to be defined to be greater than or equal to 0. We have that, so we're ready to go. So I now have all of my equations set up the way I need them, so let's put them in a matrix. So my first constraint would be 7, 2, so let's make our variables x, y, q, r, t, p, and equal sign. Okay, so it'll be 7, 2, -1, 0, 0, 0, 84. My next equation would be 3, 2, 0, -1, 0, 0, 60. Then we've got 3, 6, 0, 0, -1, 0, 72. And our objective always goes on the bottom. And that is 2, 1, 0, 0, 0, 1, 0. Okay, so here we go. We're ready to start doing our problem. So the first thing we say to ourselves, we say self. That's a Winnie the Pooh reference for anybody who does not know. Self, are we in our solution region? Let's check our answers. Well, we see because x has lots of numbers, we're going to instantly define that as x equaling 0, y equaling 0, q equals, so this we keep, r we keep, t we keep, p we keep, equal signs we always keep. So therefore, when I read across my rows, we can see this first row is giving me an answer of q, which would be -84. My next row is giving me an answer of r. So r is an answer of -60. And my next row here is giving me an answer to t, and t is -72. And we can see all these things are negative. So therefore, all of these rows we're going to star. Okay, so now because they're starred rows, what that means is we're not in our solution region. So therefore, we need to get to our solution region. I need to start heading towards any one of these lines, any one of these constraints. So therefore, pick one. Start walking. So most students always like to pick the first row. So just to be different, could we pick the third row? Absolutely. Okay, let's do that. So if we're going to head towards the third row, we're going to look for the largest slope in the positive direction. So that's 6. So that means I'm going to pivot in my y column. So in my y column, I need to test my ratios. So when I test my ratios in the y column, 84 divided by 2 would be 42. 60 divided by 2 would be 30. So far that's less. And then last but not least, 72 divided by 6. Well, we don't have to do too much thinking to know it does. We don't really need to know what this number is. We just know it's smaller. So therefore, I'm going to pivot on the 6. Now, is that the only correct pivot we could have used? Absolutely not. We could have pivoted from the middle row, saying what's the largest positive slope? 3. So I'm going to pivot in the x direction, and then you could figure out your ratios again. And I think we'd be pivoting up here just by eyeballing it. So I think either of those would be correct pivots. I'm going to do the 6. All right, so here we go. Now, pivot in the 6. So what does that mean? Use that row. Use row 3 to get zeros above and below. So what would I need to do? I would need a negative row 3 plus 3 row 1s to make a new row 1. I need a negative row 3 plus 3 row 2s. And I would need a negative row 3 plus 6 row 4s. Okay, I'm going to pause the video and fill in the algebra there. Remember, on your test, I'm grading you on the stuff we just did. Picking a correct pivot and showing me the row operators that use that pivot. The adding and subtracting that's about to follow is not very important to me, so you lose minimal points for making a mistake here. Okay, so now I hope I've done all my adding and subtracting right. Double check me. But the key things I wanted to make sure I talk about is, all right, we pivoted off of the 6. So now I have zeros above and below. So this column where we pivoted in the y direction now has all zeros except for the one number where we pivoted. Now the next thing is, normally we want to pay attention to, we're not allowed to have negatives in our equal sign column, right? No negatives are allowed there. Well, we have one. Is that okay? Yes, it is, because remember, what it's showing us here is the reflection. What we're saying is P is really negative Z, so therefore what we really have here is negative 6 is equal to negative 72, so that's a positive number. So we're okay. All right, so now let's check our answers. Let's see if we're in our solution region. So as I'm reading here, my x's, my x column, once again, x equals 0. Y we're going to keep, q we're going to keep, r we're going to keep, t is now 0. All right, over there. So let's check the rest of the stuff. Okay, so now as I read across, let's see, 0 plus 0 plus a negative 3, 180. So this row is still giving me q, and we can see q is still a negative number, so that's still getting starred. Okay, my middle row, when I read across, that's a 0 plus 0 plus 0 plus a negative 3, 0. So that's another negative number. So this is giving me r, okay? And r is still giving me a negative number, so I can star that row. And finally, in my last row, 0, 6, 0, 0, 0, 0. So 72 divided by 6, I don't really care what that number is, but what I can see is y is a positive number. So this is now giving me y, but it's positive, so that's okay. All right, so next. And what you can see here, if you kind of pay attention, we're tracking q. The first row gave me q, second row gave me r, third row gave me t. In the original matrix, I pivoted in the y column of the third row, so now notice the third row is now giving me y. All right, so now let's pick our new pivot. We either need to travel towards the first equation or the second equation. Let's do the first equation. Why not? No, you know what? Let's not do the first. Let's do the second, just because it's something different, probably different than what you would have picked. So, traveling in the second row, because it's starred, we could pick either one. Looking for the largest positive number, that would be 6. So therefore now, using the 6, we're going to go in the x direction. So we need a test. What's 180 divided by 18? Well, that's 10. What is 108 divided by 6? Let's see. Bigger or smaller than 10 is all we really care about, for now. But let's see, 6 goes into 10 one time with a remainder of 4, 6 times, so that gives us 48. 6 times 8 is 48. Bigger than 10, so we're not pivoting there. Okay, then the last one is 72 divided by 3. 3 goes into 72 two times, so this is going to be in the 20s, so that's too big. So therefore, well, I'll finish anyway. So that would be 12, so that would be 24. So therefore, 10 is our smallest number, so we're pivoting on the 18. Okay, so now, here we go. Let's do our row operators. I need to do negative row 1 plus 6 times what? 3? 3 times row 2 to make a new row 2. Then I need a negative row 1, and 3 goes into 18 what? 6 times, so that's going to be 6 row 3s. There we go. And then now I need to do a linear combination here. So let's see, that would be a negative row 1 plus, okay, I have for row 4, 2 row 4s. All right, I'm going to go ahead and pause the video as I do these row operators. Okay, so here we are, and I hope I got all my math right. Double check me. But so looking at this, let's now check our answers again. Let's see if we're in our solution region. So we're going to keep x, keep y. Q is going to be set equal to 0 because there's lots of numbers. R, we're going to keep t. We're going to set equal to 0. Keep p. All right, so here we go. Reading across in my rows. Reading across, I have 18 x's, 0, 0, 0, 0, 0, 180. The good news for this, x equals 180 divided by 18. It's a positive number. That's all I care about. Okay, y, or the next row, sorry. And you can see this first row is what gave me x. Now the next row, reading across this next row, that's 0, 0, 0, negative r's. All right. So you can see this next row is going to give me r, and it's a negative number, so we're going to need to star it. Okay, and then for the last row, 0, this one's going to give me y now. 0, and then it's 36. 0, 0, 0, 0. So 252 divided by 36. 36y is a positive number, so it's good. And so you can see it happened again. In the first row, we pivoted in the x column, and so now it's giving us an x answer. So you can kind of keep track of this stuff. I didn't make a big deal about that in the original time through, but it's just another way of looking at this stuff. Okay, so we're ready. We have one starred row, so let's look for our largest positive number in that row. That would be the Q column. So in the Q column, now we're going to look for our largest positive ratio. So 180 divided by negative 3, while that is whatever it is, we don't care, it's negative. So then what we can do is do 144 divided by 3, and we have 252 divided by 3. Without doing any real thinking, we know that's the smaller number. So therefore, we're going to pivot there. All right, so now we're ready to go. Row operators. All right, well, this is at least looks a little easier. All we're going to simply say is we do row 2 plus row 1, negative row 2's plus row 3, and negative row 2's plus row 4. There we go. They're all 3, so that made it relatively easy to make those row operators. Okay, I'm going to pause the video, and let's hope my math is okay. So now, hoping my adding and subtracting is right, let's keep proceeding with the problem. So here we go. Let's check our answers and see if we're in our solution region. So here we are. This keep x, keep y, keep q. R is equal to 0. T is equal to 0. All right, so now let's check. 324 divided by 18 for our first row, that looks good. X equals a positive number. For our second row, we're going to get Q is equal to, all right, 144 divided by 3, that's a positive number. Yay! All right, and apologies, row 1 gave us X, row 2 gave us Q, and row 3 gave us, all right, here we go, Y. And again, a positive number. So therefore, what does that mean? We're ready to start standard simplex, not general. Yay! All right, so now, what are we looking for in standard simplex? Now we start working about maximization. Now we're going to worry about finding the optimal solution since we're standing at a feasible one. So optimal solution means we can't have any negative numbers. Our slopes have to all be positive down here. So therefore, this negative 1 is no good. So we're going to travel in the t direction. So now check your ratios in the t direction. 324 divided by 3, 144 divided by 2, or 108 divided by -9. Well, we know that one's out because we can't have any negative answers, so there's no reason to walk to a negative intercept. And let's see, 324 divided by 3 is 108. Whoops, 108. And 144 divided by 2, we already know is much less than that, so there's our answer. So we're going to pivot off the 2. All right, so let's make our row operators. All right, so I'm going to need to do, let's see here, 3 row 2's, sorry, negative 3 row 2's plus 2 row 1's. I'm going to need to do, since I already have the negative, I don't need a negative here, so I'm just going to do 9 row 2's plus 2 row 3's. And then finally, I'm going to do, I already have a positive and a negative, so I just need row 2 plus 2 row 4's. Once again, I'm going to pause the video. Let's hope my math is correct. Okay, so now hopefully my math is right. I did all the row operators and this is what I came up with. So now the good news, when you notice in our bottom row, there's no negatives, no negative variables, so therefore we're at our optimal solution. So now let's interpret it. Okay, finally I get to cross stuff out. Q we set it's equal to 0, R we set equal to 0, and we're going to keep everything else. So in our first row we're going to get 36x's equals 216. So when I solve that, let's see, what's 216 divided by 36? Just using my calculator off the screen. That is 6. All right. Then for my next equation, we're going to get, let's see, when I read across, we're going to get 2t's equals 144. That's a slack variable. We don't need that. And then our next one is 72y's is equal to 1,512. So therefore, 1,512 divided by 72 is 21. Okay, last but not least, for our objective equation, we can see 0x, 0y, 0q, 0r, 0t. So we're just going to end up with 24p's is equal to negative 792. And if you remember, p was really the same thing as negative z way back up above. So therefore negative 24z is equal to negative 792. So therefore negative 792 divided by negative 24, it means z is equal to 33. So what we can say now is we know we have a min of 33 at 6,21. And the good news about this is I had already done the problem in another video where I did it via graphing. So therefore, if I bring up that quick graphing video, you can see very quickly the answers I had come to in this problem. See if we can jump a tiny bit further. Well, nonetheless, you can see the answer I came to on this was C. The minimum was at 621, and it was a minimum of 33. So looks like we got the exact same answer. Fantastic! Which therefore means probably all my adding and subtracting was correct, or if I did, it didn't end up affecting the problem if I made a mistake. But nonetheless, there you go. General simplex method. Now, I will point out one other thing that would have made our life a little easier, I just didn't do it, is you'll notice back in some other matrices, like for example in this one right here, I believe all of these numbers are divisible by 3. So we could have divided that whole row by 3. And I believe here all these numbers are divisible by 9. So we could have divided that row by 9. And it just would have kept our numbers a little smaller, made it so our row operators weren't so messy. But any which way, we got there. I hope this helps.